Welcome to The Explainer. Today, we're unpacking a truly fascinating set of concepts drawn straight from the Computer Underground Railroad publications. We're going to dive deep into the fact that we are rapidly accelerating toward a brand new wireless era. It's an AI-native future, and it's going to be characterized by massive, invisible data flows and an unprecedented density of electromagnetic frequencies. I mean, we've all felt the speed of this technological wave, right? But what is genuinely captivating about our source material today is the deeply surprising solution it proposes. To navigate this hyper-advanced future, the author doesn't just look forward to next-generation metallic alloys or synthetic chemicals. Actually, they look backward. They look to one of humanity's oldest, most historically rooted ancient crops, hemp. It's a completely wild exploration of how an entirely natural plant might just serve as a protective, breathable shield in an artificially intelligent world. Our explainer today is going to follow a really cool Russian doll progression. We'll start with part 1, the 6G and AI era, then 2, hemp as a natural shield, 3, printing sustainable hemp homes, 4, making homelessness ancient, and finally 5, green data center infrastructure. Let's jump right in. Section 1, the 6G and AI era. So the source material highlights that our transition into this new era isn't just some slow, gradual evolution. Not at all. It is an incredibly aggressive global race, driven by major industry leaders and a very specific December 2025 White House directive. There is this massive, coordinated push to bring 6G fully online by the end of this decade. Now, to truly grasp the magnitude of this shift, we really have to conceptualize the sheer volume of data moving through the air around us. The author points to predictions from telecom leadership, specifically Qualcomm, who predict that global cellular traffic could grow by a staggering 7-fold by the year 2034. 7 times the traffic. Think of our current wireless data environment like a regular garden hose. Within a single decade, that flow is expected to become a high-pressure fire hose of constant, ambient information just rushing around us. Now, you might be wondering, what exactly is driving this massive spike? Well, surprisingly, it's not simply humans streaming more movies or infinitely scrolling social media. Artificial intelligence alone is projected to account for nearly a full third, about 33% of that massive future data load. We are fundamentally moving away from a world where cellular networks exist strictly to connect humans to other humans. Instead, we are building a reality where networks are primarily utilized to connect intelligent machines, autonomous agents, and massive predictive models to each other in real time. They'll be functioning continuously, silently, right in the background of our everyday lives. The absolutely crucial takeaway here is understanding the physical environment this new infrastructure creates. That December 2025 White House directive calls for aggressive spectrum reallocation and the deployment of incredibly dense AI-driven radio access networks. And these networks, they won't just be sitting on distant cell towers out on the highway. They will be embedded absolutely everywhere. Inside our homes, our vehicles, public spaces, and even seamlessly integrated into our clothing. The author impartially raises a highly significant concern regarding all of this, the biological and environmental impact of a dramatically intensifying electromagnetic environment. They argue that we are rapidly accelerating our chronic, daily exposure to elevated radiation and EMF levels. That's the literal biological load placed on our bodies, and we're doing it without fully understanding the long-term consequences of living inside the dense nervous system of an AI economy. Which brings us to a critical, profound question posed by the communities in our source text. How exactly do we protect human biology in an era of constant, unavoidable electromagnetic exposure? Seriously, if we cannot escape the invisible waves powering our future, how do we adapt our environments to safeguard our health? Let's take a look at the author's deeply unexpected answer. Section 2. Hemp as a natural shield. The author proposes that instead of fighting complex technology with even more heavy metals or synthetic petrochemicals, we can actually turn to hemp-based materials to create healthier living spaces. The source outlines 3 specific pathways for building this EMF-aware architecture. First up is Hempcrete. This is a breathable, fire-resistant biocomposite that creates incredible thermal mass. It regulates temperature naturally while heavily reducing indoor ambient noise. Second is hemp graphene, a highly specialized nanomaterial capable of EMF attenuation. And third is hemp fabrics, which are natural fibers engineered into functional shielding textiles. Together, these 3 things form a complete regenerative toolkit. Now, that second pathway is arguably the most futuristic part of this whole equation. The author defines hemp graphene, which is specifically derived from the inner bast fiber of the hemp plant, as a highly conductive, very lightweight nanomaterial. When this is integrated into interior plasters, paints, or building composites, the source claims it can create renewable, non-toxic, Faraday-like shielding layers all around a room. If you're familiar with a Faraday cage, you know it blocks electromagnetic fields. Well, this applies a similar principle, but entirely naturally. These walls are actually designed to reflect EMF, absorb RF energy, and safely dissipate those ambient electromagnetic waves as harmless heat. It's pretty amazing. And this protection extends far beyond the walls of a house. It goes right into personal autonomy. By weaving carbonized hemp threads or graphene-infused fibers into everyday textiles, we can create clothing, curtains, and interior design elements that offer literal, wearable protection against the constant chatter of 6G devices communicating all around us.
Section 3. Printing Sustainable Hemp Homes.
Building on those micro-level materials, we now scale up to entire habitats. As our electromagnetic environment intensifies, the very way we construct our homes becomes absolutely critical, and the source points to large-format 3D construction printing as the ultimate vehicle to make this happen. And the speed of this proposed solution, it's genuinely staggering. The author emphasizes that by using evolving drone and laser printing tech, we can extrude these hemp-based geopolymers to build a complete move-in-ready home in less than 90 days. We're talking under 3 months. And it creates almost zero construction waste while offering vastly superior insulation compared to traditional builds. When we shift the materials, we also naturally shift the geometry. We move away from traditional box-shaped buildings and sharp corners, favoring organic, curved structures like domes and cylinders. Extruding hemp bioplastics allows for these fluid, natural shapes, which the source argues heavily outperform traditional boxes. They offer superior wind and seismic resilience, allowing harsh weather to simply roll right over them. But most importantly for our topic today, continuous curves create a much calmer EMF profile. Why? Because there are no hard 90-degree corners for electromagnetic waves to intensely bounce off of and amplify within. It's like acoustic dampening, but for invisible waves. And these aren't just empty shells either. They are designed as deeply living, self-sustaining ecosystems. These 3D printed homes feature a waterproof hemp plastic exterior shell, and they operate internally on completely battery-free microgrids utilizing clean magnetic and solar energy. But perhaps the absolute most amazing feature detailed by the author is the central atrium. It's a greenhouse integrated right into the center of the living space, and this atrium is equipped with atmospheric water generators. Just imagine waking up in a self-sustaining ecosystem, walking into the center of your house, and pouring a glass of clean, purified drinking water that was quite literally pulled directly from the thin air around you. It's a vision of a truly autonomous, self-contained sanctuary.
Section 4. Making Homelessness Ancient.
The author emphatically states that homelessness is a human-made problem, which means, by definition, it fundamentally has human-made solutions. They use a really striking spatial comparison to prove that this is a highly solvable logistics issue. There are roughly 800,000 unhoused people in the United States right now. To put spatial efficiency into perspective, the source points out that back in 2019, 1.5 million people lived comfortably on less than 25 square miles in Manhattan. Therefore, by using underutilized land, and they use Cochise County, Arizona as a prime example, we could beautifully and sustainably house the entire U.S. homeless population on a footprint of just 25 square miles using these rapidly printed 3D hemp homes. Just 25 square miles. But housing alone isn't enough, right? People need income, stability, and a sense of purpose. This is exactly where AI re-enters the narrative. Not as an EMF concern this time, but as a deeply powerful tool for economic liberation. By pairing newly housed individuals with trained AI agents, residents can generate remote income through digital microwork, virtual tutoring, and creative content creation. Think of the AI as a daily partner. It acts as a digital coach and a mental health stabilizer that can tirelessly help vulnerable individuals reintegrate, learn brand new skills, and economically thrive, all from the complete safety of their autonomous homes. I want to read this exact quote directly from the source material because it really anchors the author's entire philosophy here. Homelessness is not a lack of character, it is a lack of access. When people are housed in beauty, when they are surrounded by physical safety and supported by infinite technological patience, human genius naturally rises to the surface. Section 5. Green Data Center Infrastructure. Okay, so this brings us to the absolute macro level of our Russian doll. We've talked about protecting humans from AI networks and using AI to uplist humans, but what about the physical infrastructure that makes AI possible in the first place? I'm talking about the massive data centers. The source material impartially outlines the very real environmental weight of cloud computing. These massive facilities require extreme electricity consumption and heavy municipal water usage just for cooling down the servers. They generate localized noise pollution, intense heat, actual mountains of electronic waste, and put immense pressure on local land use. While AI is clearly too valuable to abandon, the author argues we simply cannot afford to be environmentally careless with its foundation. The proposed solution scales up everything we've just been discussing. It is the ultimate test of our progression today. Imagine next-generation data centers built with massive 3D-printed hempcrete walls for natural fire resistance and heavy carbon storage. Imagine server cooling systems that use atmospheric water harvesting instead of draining vital local municipal water supplies. Add in structural hemp-based Faraday shielding to protect the sensitive electronics and power the entire complex with dual clean energy microgrids. It's a fully integrated environmental design strategy that completely harmonizes cutting-edge technology with the natural world. Which leaves us with this final profound question to consider today. Can ancient natural plants, like hemp, and futuristic artificial intelligence truly coexist to heal our planet? The source material we explored today certainly argues that they can, provided we have the courage and the will to combine them thoughtfully. It's an incredibly fascinating vision of a regenerative, AI-empowered future that protects both human biology and the Earth itself. Thank you so much for joining me for this explainer, and I really hope it left you with some deeply inspiring new ideas to think about as we build tomorrow.